So, picture a 32-year-old marathon runner.
Okay.
They eat a really balanced diet, whole foods, mostly organic. They've never smoked a day in their life. They barely drink, and they have absolutely zero family history of serious disease.
Right. So by all conventional measures of modern health, they're doing everything right.
Exactly. Everything right. Yet, they are sitting in a gastroenterologist's office looking at a scan that shows stage 3 colon cancer.
Yeah. And it's a scenario that leaves both the patient and the doctor completely reeling.
Because it just doesn't make sense, right?
It doesn't. It violates every single rule we learned in medical school about, who gets this disease and when they get it.
Welcome to our deep dive. For you, the learner tuning in today, we are embarking on a mission to unravel what is arguably one of the most pressing and honestly terrifying medical mysteries of our generation.
It really is.
We're looking at the exploding rates of cancer in young adults, specifically people under the age of 50.
But before we go any further, I think we need to set the parameters for this conversation.
Yeah, that's important.
Because the goal today is not to induce a panic attack. We aren't here to make you terrified of every ache or, every random stomach pang or every hour of sleep you happen to miss.
Right, nobody needs more health anxiety.
Exactly. This is about awareness. We're taking a massive stack of recent global studies, oncological research, and epidemiological data, and we're translating it into actionable knowledge.
Because ultimately, knowledge is the only way you can protect yourself. But to understand the mystery of why this is happening to younger people, we really have to understand the baseline.
Right? We have to start from the beginning.
Yeah, let's build this from the ground up because we can't assume everyone knows the underlying biology here. I've always liked thinking of the human body as a highly functioning, massive metropolis.
I love that analogy.
Right. A city where the cells are the citizens. And under normal circumstances, you have this expectation of order. Traffic lights tell the cars when to stop, garbage trucks clear away the waste, and zoning laws keep the heavy industrial factories out of the quiet residential neighborhoods.
That's a highly accurate way to visualize it, actually.
Yeah.
Your biology relies on trillions of these interconnected processes.
Trillions. It's wild to think about.
It is. And every single cell has a very specific job. The skin cells form the barrier, the immune cells patrol for invaders, the red blood cells run the transport network.
Like the city transit system.
Exactly. And they all stay in their designated lanes, following a really strict set of biological laws.
So in the context of the city analogy, what actually is cancer? Because, we use the word all the time. But stripped of the medical jargon, what is happening on a cellular level?
Well, at its most basic level, cancer begins with a single normal citizen, a single cell that slowly, over a period of time, just breaks the rules of the city.
Just one cell going rogue.
Just one. It usually starts with an accumulation of mutations in the cell's DNA, which is basically its instruction manual. And these mutations act like corrupted computer code.
Like the zoning laws suddenly getting deleted from the city's server?
Or the traffic lights all turning green at the exact same time.
Oh, wow. Total chaos.
Right. So the cell begins growing and dividing out of control, totally ignoring the signals from the body that tell it to stop.
And the body just lets it. Doesn't the immune system step in?
Normally, yes.
Wow.
But a cancerous cell figures out how to evade the immune system. It basically hides from the city's police force.
That is incredibly sneaky.
It gets worse. It even learns how to avoid a process called apoptosis.
Apoptosis, what is that exactly?
It's programmed cell death. It normally acts as a self-destruct mechanism for damaged cells. If a cell knows it's corrupted, it's supposed to sacrifice itself for the good of the body.
But the cancer cell disables the self-destruct button.
Exactly. And eventually, in its most dangerous phase, this rogue cell gains the ability to spread.
Metastasis, right?
Yes, it metastasizes to other tissues.
Yeah.
It becomes an invasive force, building new, chaotic neighborhoods where they don't belong and just siphoning off the body's resources.
And traditionally, going back decades, we've always thought of that rule-breaking process as a disease of aging.
We have, yeah.
The old story of cancer was that it belonged to the later chapters of life. It was something you worried about in your 70s or 80s.
And there's a very sound mechanical reason for why that was the prevailing wisdom.
Which is?
Well, for most of human history, cancer was quite literally a disease of time. The longer you live, the more times your cells have to divide just to maintain your basic tissues.
Right. Skin replaces itself, stomach lining replaces itself.
Yeah, exactly. And every single time a cell divides, it has to copy billions of letters of DNA.
Billions. That's a lot of room for error.
Precisely. Every division carries a tiny, microscopic risk of a copying error.
I think of it like trying to hand copy a massive million-page manuscript. If you copy it once, maybe you make a couple of typos.
Right.
But if you copy it 50 times, you're going to drop entire sentences.
That's a perfect way to look at it. Now, most of those typos are caught by the cell's internal proofreaders.
Okay, so we have built-in spell check?
We do.
Hmm.
But over decades of biological wear and tear, those uncorrected mutations just start to add up.
Because nothing works perfectly forever.
Right. Plus, your internal repair machinery naturally becomes less efficient as you age.
So the proofreaders get tired.
They get tired, they miss things. So eventually, one cell gets just the right catastrophic combination of typos that tells it to never stop dividing.
And that leads to a tumor.
Yes. Time and age were always the primary drivers. That was the old rule book.
But the old rule book is basically being thrown out the window right now, isn't it?
It really is.
Because doctors are now seeing people in their 20s, 30s, and 40s getting diagnosed with cancers that shouldn't biologically belong to them yet.
It's alarming.
We're talking about people who are busy building careers, raising toddlers, and living what look like vibrant, healthy lives.
And it's not just one rare genetic fluke of a cancer either.
Right, it's happening across multiple organ systems all over the globe.
The sheer scale of this shift is what's keeping epidemiologists up at night. I mean, it's forcing the entire medical establishment to question everything we thought we knew about the timeline of cellular mutation.
So let's lay out the actual data from the studies we reviewed for this deep dive,
Yeah.
because I think it's important to ground this mystery in hard numbers.
Good idea. The numbers are pretty stark.
According to a massive global analysis looking at data spanning from 1990 to 2019, the global incidence of early-onset cancer, which the medical community defines as cancer diagnosed in adults under 50, rose by a staggering 79.1%.
Almost an 80% jump.
Yeah. And during that same window, the mortality rate for these early-onset cancers went up by 27.7%.
So more young people are getting it, and more young people are dying from it.
Exactly. And if we zoom in specifically on the United States, researchers analyzed 34 different types of cancer.
Right, a really comprehensive look.
They found that 14 of those 34 showed significant, measurable increases in younger age groups.
We are talking about sharp upward trends in very specific areas. Cancers of the colorectum, breast, kidney, pancreas, stomach, and uterus.
There's also a really stark divide between the sexes in this younger demographic rate.
There is, yes.
Women under 50 are bearing a disproportionate burden here. The incidence rates for women in this age group are currently 82% higher than their male counterparts.
Which is a massive gap.
And the research notes this is heavily driven by spikes in breast and thyroid cancers.
Now, I know what a lot of people might be thinking when they hear those numbers.
Yeah, I have to stop and play the skeptic for a second, because I know exactly what I'd be thinking if I were listening to this on my commute.
What's that?
Aren't we just finding more cancer because our technology is vastly superior to what we had in 1990?
The screening argument.
Right. We have high-resolution MRIs, incredibly sensitive biopsies, and, we're just screening a lot more people in general. Doesn't the better technology explain the spike?
It's the most logical first question to ask. And honestly, it was the very first hypothesis scientists tested when they saw the data.
So does it hold up?
The answer is highly nuanced. Increased screening definitely plays a small role in the data.
Okay.
Improved protocols for cervical cancer and bringing mammography to younger demographics for breast cancer, those things do account for some of these earlier diagnoses.
Which is a good thing because we're catching it.
Yes, absolutely.
Yeah.
But screening does not come close to explaining the whole picture.
Why not?
Well, because we aren't handing out routine MRIs to healthy 25-year-olds to check their pancreas.
That is a very fair point.
That's the crux of it, really. We are seeing massive, undeniable spikes in cancers that we simply do not routinely screen young people for.
Right. There is no standard population-wide screening protocol for stomach cancer in a 30-year-old.
Exactly. Or pancreatic cancer. Or
Yeah.
kidney cancer in someone who has absolutely no symptoms. Yet the rates for those specific diseases are climbing.
So they're finding it another way.
Yes. And even more concerning, for many of these gastrointestinal cancers, patients are still presenting with advanced late-stage disease.
Oh, wow. Meaning the cancer wasn't caught early by some fancy new proactive test.
No, it wasn't.
It was caught because the tumor grew so large it started causing severe, undeniable symptoms that forced them to go to the hospital.
Exactly. Which proves we are looking at a genuine epidemiological shift. The actual biological risk of developing cancer at a younger age has tangibly increased.
It's not just an illusion of the data.
Not at all.
That brings us to one of the most crucial concepts in the research we reviewed. It's called the birth cohort effect.
This is a fascinating concept.
Can you explain how this works? Because it really reframes how we look at the timeline of health.
So when epidemiologists look at massive data sets, they group people by the decade they were born, their birth cohort.
Like boomers, millennials, Gen Z.
Exactly. And what the current data reveals is that a person born in 1990 has a measurably higher risk of developing certain cancers than a person who was born in 1950 did when they were at that exact same age.
Wait, let me make sure I'm understanding this. So when a boomer was 35, their risk of colon cancer was objectively lower than a millennial's risk is today at age 35.
Yes, that is exactly what the data shows. And the risk seems to be stepping up almost like a staircase with each successive generation.
Wow.
Generation X has a higher baseline risk than the baby boomers, and millennials have a higher risk than Generation X.
If we synthesize that, it rules out a couple of major things pretty quickly.
It does.
I mean, it can't just be genetics, right? Human DNA across the entire global population doesn't just mutate that drastically in the span of 1 or 2 generations.
Right. Evolution takes thousands of years, not 30.
And we just established it isn't merely an artifact of our screening machines getting better.
Correct.
So if it isn't our inherited genes and it isn't the technology, it has to be something in how we are living.
That's the only logical conclusion.
The environment we are exposing our bodies to must be fundamentally altering how our cells behave on a daily basis.
And scientists have a specific all-encompassing term for this environment. They call it the exposome.
The exposome.
Yeah. And in the context of early-onset cancer, researchers are heavily focused on the early life exposome.
I love that term because it sounds like a sci-fi concept, but it's incredibly practical when you break it down.
It really is.
It essentially means the totality of every single exposure a person experiences from the moment of conception straight through to young adulthood.
Right. Think of it as a massive bucket containing absolutely everything your body interacts with.
What's in the bucket?
Well, it encompasses the food you eat, the air pollution you breathe, your sleep architecture, your chronic psychological stress.
Medications too?
Yes, the medications you take, the synthetic chemicals in your environment, your physical activity levels, and, crucially, the trillions of microbes living inside your gut.
So it's basically the sum total of your biological interaction with the outside world.
Exactly.
Okay, before we start pulling apart the specific elements of this exposome bucket, I want to do some quick myth-busting for you listening.
Very necessary.
Because if you spend 5 minutes looking up cancer on social media, you'll find 100 different influencers shouting that they have found the singular, secret cause of all modern illness.
Oh, the internet is terrible for this.
Based on the scientific consensus in our sources, it is entirely inaccurate to point to one thing and say sugar directly causes cancer, or seed oils are the sole reason young people are getting sick.
We have to be incredibly careful to avoid that kind of reductionist thinking.
Right.
There is zero credible scientific evidence that cell phone radiation or microplastics or any single dietary ingredient is the lone villain here.
It's just not that simple.
No, we are not dealing with a single smoking gun in the way that, say, tobacco smoke was the clear, undeniable driver for the lung cancer epidemic of the 20th century.
And I want to highlight something really important for the learner. We cannot, under any circumstances, blame young people for their diagnoses.
Absolutely not.
If a 32-year-old gets colon cancer, it isn't simply because they didn't eat enough organic kale or because they drank diet soda in high school.
The guilt that some of these young patients carry is heartbreaking, and it's medically unjustified.
It really is.
Blame is worse than useless. It obscures the actual science. The consensus is that this is a deeply multifactorial issue.
A slow buildup over time.
Yes, we are looking at the slow, silent accumulation of dozens of modern exposures that are subtly changing our internal biology at a systemic level.
Yeah.
It's a really complex web of gene-by-environment interactions.
So let's pull on one of the thickest threads in that web. Modern metabolism.
Okay, let's go there.
We've witnessed a massive shift in how humans fuel themselves since the mid-20th century, right? The rates of obesity, type 2 diabetes, and metabolic syndrome have just skyrocketed globally.
They have. It's a parallel epidemic.
And this tracks perfectly alongside the normalization of diets that are extremely high in ultra-processed foods, refined grains, and sugary beverages.
It does.
But I want to connect the dots here. How does eating a highly processed diet actually translate into a rogue cell mutating and dividing? I mean, what is the bridge between a fast food burger and a DNA typo?
To understand that, we have to look at how we view body fat, because our understanding has changed a lot.
How so?
For a very long time, medical science treated fat tissue, adipose tissue, as just a passive storage locker, an inert savings account for excess calories, basically.
Right, just energy waiting to be used.
But we now understand that this was completely wrong. Fat is actually a highly active endocrine organ.
Wait, so it isn't just sitting there.
Yeah.
It's actively producing things and sending signals to the rest of the body.
Constantly. Excess fat tissue, particularly visceral fat, which is the kind that wraps around your internal organs, releases a steady stream of inflammatory molecules.
Okay.
You'll often hear these referred to as cytokines in the medical literature.
Okay, proxy for the listener here. I've heard the word cytokine thrown around a lot, especially since the pandemic. What is a cytokine doing in my body on a normal Tuesday?
A cytokine is essentially a chemical messenger used by your immune system.
Like a flare gun.
Exactly. If you cut your finger, cytokines signal the immune troops to rush to the area, causing local inflammation to heal the wound.
Which is good. We want that.
We do.
Hmm.
But when visceral fat constantly pumps out cytokines, it creates a state of chronic, low-grade systemic inflammation.
The flare gun is always going off.
Yes, the immune system is constantly being told there's an emergency, but there's no cut to heal.
Going back to our city analogy, it's like the fire alarms are going off in every neighborhood 24 hours a day, but it's just a bunch of tiny, smoldering trash can fires.
That's a brilliant way to frame it.
And the fire department, your immune system is constantly rushing around, exhausted, overworked, and depleted.
Right. They can't do their actual job of patrolling for cancer cells because they're dealing with this constant low-level inflammation.
That makes so much sense.
And beyond the cytokines, active fat tissue also alters how your body processes hormones.
How does it do that?
Well, for instance, adipose tissue contains an enzyme that literally takes other hormones and converts them into estrogen.
Really? Just manufactures estrogen?
Yes, and this is a primary reason why metabolic syndrome is heavily linked to hormone receptor-positive breast cancers and uterine cancers.
Because more fat equals more circulating estrogen.
Exactly, which can act as a direct growth signal for those specific tissues. It tells the cells to multiply.
There's also the insulin factor mentioned in the sources,
A
right?
huge factor.
If you're eating a diet high in refined sugars, your body has to pump out more insulin just to keep your blood sugar from reaching toxic levels.
Correct. And insulin itself acts as a potent growth factor for cells.
So you have this triad going on.
Yes, you are bathing the cells in growth factors like insulin that tell them to multiply. You are altering hormones like estrogen that can fuel tumor growth. And you are maintaining a state of chronic inflammation.
The sources also mention that chronic inflammation leads to something called oxidative stress. Can you break that down? Because it sounds like my cells are having a panic attack.
Oxidative stress is basically biological rusting.
Resting.
Yeah. When your metabolism is overworked and inflamed, it produces these unstable molecules called free radicals.
I've heard of free radicals in the context of antioxidants, right?
Like antioxidants neutralize them.
Yeah.
But if you have too many free radicals, they zip around and literally rip electrons off of your cellular structures, including your DNA.
Oh, wow. So they physically damage the instruction manual.
They do. They cause those typos we were talking about earlier.
So tying it all together for the listener, you're increasing the rate of DNA damage through oxidative stress, while simultaneously providing the growth signals like insulin and estrogen for those damaged cells to multiply.
Yes.
You're essentially rolling out the red carpet for cancer.
You are creating a microenvironment where an abnormal, rule-breaking cell has a vastly superior chance to survive, multiply, and thrive compared to a healthy, well-behaved cell.
That makes perfect mechanical sense. But this brings us to a really disturbing paradox in the research.
The healthy patients.
Right. We are seeing these early onset cancers in young patients who do not fit that metabolic profile whatsoever.
It's true.
We're talking about the marathon runner from our opening example. People who eat whole foods, people who are incredibly lean, their insulin is fine, and they are still getting diagnosed.
It's the part of the mystery that is most alarming for researchers, because it tells us definitively that obesity and metabolic syndrome alone cannot explain the entirety of the trend.
The exposome bucket is much broader than just our body mass index.
It is. So, to find the missing pieces, researchers realized they had to look deeper inside the body. They had to look right into the gut.
Which brings us to ground zero of this entire deep dive. Colorectal cancer.
This is where the data is most striking.
If we want to understand this generational shift, colorectal cancer is the clearest, most aggressive example.
The rates have been climbing so sharply in the under 50 population that it has fundamentally forced public health organizations to lower the recommended screening ages.
It used to be 50 for a colonoscopy, right? And now it's 45.
Exactly. And some argue it should be even lower based on family history.
So to understand why colorectal cancer is acting as the canary in the coal mine for this generation, we have to look at the anatomy of the threat. Why the colon?
Well, the colon is essentially the ultimate biological collision point.
What do you mean by that?
Every single day, everything you consume, the food, the liquid, the food dyes, the emulsifiers, the artificial sweeteners, the environmental chemicals, it all eventually meets and interacts with your immune cells and your delicate intestinal lining right there in the colon.
It's the final processing plant.
Yes. And it isn't just a simple interaction between food and human tissue. There's a third party involved.
The microbiome. I always joke that humans are basically just walking, talking mecha suits designed to transport trillions of bacteria from one meal to the next.
It's a funny image, but biologically, it's not far off at all.
Really?
Yeah. You have to think of your gut microbiome as a massive, bustling rainforest ecosystem located entirely inside your digestive tract.
A rainforest.
Yes. It is teeming with roughly 39 trillion bacteria, viruses, and fungi.
39 trillion. That's hard to even comprehend.
And just like a physical rainforest, when the ecosystem is diverse and balanced, it provides incredible life-sustaining benefits.
Right, they aren't just freeloaders living in our gut.
Not at all. They help us digest complex plant fibers that our own stomachs can't break down. They synthesize vital vitamins like vitamin K.
And they train the immune system, right?
Yes, they are constantly training our immune system, essentially teaching it the difference between a harmless piece of broccoli and a dangerous pathogen.
The communication between these microbes and our human cells must be insanely complex.
It is breathtakingly complex. They are active participants in our biology. Let's look at dietary fiber, for example, because this is crucial to the cancer conversation.
Okay, let's talk about fiber.
When you eat a bowl of lentils or an apple, your human enzymes can't digest the fiber. It passes right through your stomach intact.
Right, roughage.
But when it reaches the colon, the good bacteria in your gut feed on that fiber. They ferment it.
They eat what we can't.
Exactly. And in that fermentation process, they manufacture byproducts called short-chain fatty acids.
The sources highlight one of these fatty acids in particular as being incredibly protective, something called butyrate. I admit I hadn't heard of it before reading the research for this.
Butyrate is a superstar molecule. It serves as the primary energy source for the cells lining your colon.
It literally feeds the barrier.
Yes, keeping it tight and strong. But beyond acting as fuel, butyrate has potent anti-inflammatory properties.
It puts out those smoldering trash can fires.
Exactly. And studies have shown it can actually inhibit cancer progression.
How does it do that?
By entering the colon cells and regulating their cell cycle. It essentially forces abnormal cells to slow down, or it triggers that programmed cell death apoptosis that we talked about earlier.
Wait, so by simply eating fiber, you are feeding the bacteria, which then manufacture a chemical shield that actively protects your DNA.
And that is exactly what happens.
That is incredible. But this is where the modern lifestyle comes in and ruins everything, right?
Unfortunately, yes.
Because modern life is essentially acting as an invasive species moving into that rainforest.
The clinical term is dysbiosis. It means an ecosystem severely out of balance.
And what causes dysbiosis?
Well, the standard Western diet, which is notorious for being high in red meats, highly processed, simple carbohydrates, and shockingly low in fiber, is a disaster for this ecosystem.
Because if you don't eat fiber, you literally starve those beneficial butyrate-producing bacteria.
Yes, they have no fuel, so they die off.
And nature abhors a vacuum.
Always.
If the good bacteria die, something else is going to claim that real estate. It's like an invasive weed taking over a garden because the soil pH changed.
That's a great analogy. When the beneficial bacteria recede, opportunistic, potentially pathogenic bacteria multiply to fill the void.
And this isn't just about getting an upset stomach, is it?
No, it's much more serious. Some of these bacteria are actively pro-tumorigenic.
Pro-tumorigenic, meaning they cause cancer.
Yes. The research highlights specific strains of E. coli, for instance, that produce a toxin called colibactin.
Polybactin.
Yes, it's a genotoxin.
Meaning it damages genes.
Exactly. This chemical, produced by the bacteria, is capable of crossing into the human colon cells and physically snapping the strands of human DNA.
What? The bacteria break our DNA?
Yes, it induces genomic instability right there in the colon lining.
That is mind-blowing. So, through a poor diet, you can cultivate an overgrowth of microbes that are actively promoting the very mutations that lead to cancer.
You're basically farming your own carcinogens in your gut.
Wow. But food isn't the only thing shaping this ecosystem, right?
Not at all.
We have to talk about a medical intervention that completely changed the trajectory of human health in the 20th century. Antibiotics.
This is a highly sensitive topic, and we need to be clear.
Yes, antibiotics are undeniably one of the greatest life-saving discoveries in the history of medicine. They cure lethal infections. No one is suggesting we abandon them,
Right. But we have to acknowledge their collateral damage.
because they are essentially weapons of mass destruction for the microbiome.
They are. An antibiotic does not distinguish between the pathogenic bacteria causing your sinus infection and the beneficial bacteria in your gut producing your butyrate shield.
It just wipes out both.
It's carpet bombing.
The sources indicate that early life antibiotic use is under intense scrutiny right now in relation to this early onset cancer trend.
Yes, researchers are looking very closely at this.
What happens when a child gets, 4 or 5 courses of broad spectrum antibiotics for ear infections before they are 5 years old?
The research is deeply compelling.
Yeah.
Now, while correlation doesn't definitively prove causation, the associations are very, very strong.
Because childhood is when the microbiome is forming.
Exactly. The early years of life are when the microbiome is establishing its foundational diversity. Repeatedly bombing that ecosystem with antibiotics during those formative developmental years can drastically alter its trajectory.
It never really recovers its full diversity.
Right. It may permanently weaken the intestinal barrier and create a long-term environment where those pro-tumorigenic bacteria, like the ones making Colobactin, can establish a permanent foothold.
And the origins of this dysbiosis can track back even earlier than childhood. The exposome starts before we are even born.
It does.
The sources mention that the development of a healthy infant microbiome is influenced by the maternal diet during pregnancy and, crucially, the method of delivery.
Yes, whether a child is born via C-section or a vaginal birth makes a massive difference in their initial microbial colonization.
How so?
Well, during a vaginal birth, the infant is coated in the mother's microbes, which act as the starter seeds for their gut microbiome. A C-section bypasses that process entirely.
And infant feeding methods matter too, right?
Immensely. Breast milk contains specific complex sugars called human milk oligosaccharides.
Let me guess, the baby can't digest those sugars either.
Spot on. The baby gets absolutely no direct nutritional value from them.
That's wild, so why are they there?
Those complex sugars exist purely to feed specific beneficial bacteria in the infant's gut.
It's an evolutionary mechanism to ensure the right microbes thrive from day one.
Exactly. And formula feeding, while sometimes necessary and absolutely life-saving, it just doesn't replicate that complex prebiotic environment.
If we count all of this back to the birth cohort effect we discussed earlier, the timeline starts to make chilling sense.
It really does.
Think about it. The generation born in the late 1980s and 1990s was perhaps the first to experience the full compounded weight of all these changes simultaneously.
Yes. Widespread, casual pediatric antibiotic use.
The explosion of ultra-processed convenience foods.
Rising rates of C-sections.
Changing infant feeding practices, and much more sedentary lifestyles. The table was basically set for dysbiosis from the day they were born.
They inherited a completely novel early life exposome, one human beings had never seen before. And we are just now, 30 years later, seeing the biological consequences of that shift.
I want to pivot here, but not to a totally disconnected topic, because if the gut is ground zero, how do our lifestyle choices outside the kitchen affect this?
Good question.
The exposome isn't just what we swallow. The sources highlight 2 massive, often ignored factors: sleep and chronic stress.
These are huge pieces of the puzzle.
Does a lack of sleep actually change our cellular risk, or is it just making us tired and, more likely to eat junk food the next day?
It changes your cellular risk on a fundamental level. Sleep is a non-negotiable pillar of human biology that modern society has significantly compromised.
And the data here reveals a surprising trend, right?
Yes. When researchers at Harvard looked at sleep durations over the last few decades, they found that adult sleep hasn't actually declined as drastically as we might assume.
Really? I feel like everyone complains about not sleeping enough.
They do, but the baseline hasn't shifted enormously for adults. But the sleep duration for children and adolescents has absolutely plummeted.
Oh, wow. Kids are getting far less sleep today than any previous generations.
Significantly less, yes.
But why does a sleep deficit at age 12 matter for a cancer diagnosis at age 35? How does that mechanism work?
Because childhood and adolescence are critical windows for immune and metabolic development.
Okay.
Sleep isn't just resting. It is an active state of biological maintenance. When you enter deep sleep, your body literally clears metabolic waste from your brain and tissues.
The garbage trucks are running.
Exactly. And more importantly, your immune system uses that downtime to perform surveillance. It hunts for those rogue, misbehaving cells and clears them out.
So if you are chronically cutting that maintenance window short by 2 hours a night for a decade, those misbehaving cells are ignored.
They slip through the net.
That's terrifying.
Yes. Furthermore, chronic sleep disruption alters insulin sensitivity and elevates your baseline levels of cortisol, the stress hormone.
So you are shifting the body into a state of chronic low-grade stress and disrupted cellular repair before adulthood even begins.
You are. Which perfectly sets up a concept from the source material that genuinely stopped me in my tracks when I first read it.
The idea of accelerated aging.
Yeah.
Can you walk me through this? Because clearly we aren't talking about getting gray hair in your 20s.
No, we aren't. Accelerated aging refers to the growing disconnect between chronological age and biological age.
Okay, chronological age is simply the number of years since you were born.
Right. And biological age is a measure of the cellular wear and tear your tissues have accumulated.
How do they measure that?
Researchers can determine this by looking at specific microscopic markers. Two of the most prominent are telomere length and DNA methylation patterns.
Okay, pretend I dropped high school biology. What does a telomere or a methylation pattern actually look like inside my cell?
Think of a telomere as the little plastic cap at the end of a shoelace.
The aglet?
Right, the aglet. Your DNA is the shoelace. Every time a cell divides, that plastic cap gets just a tiny bit shorter.
Okay, so it wears down.
Yes.
Yeah.
Eventually, the cap wears off completely, the shoelace frays, and the cell can no longer divide safely. It enters a state of retirement. That's normal aging.
And what about the methylation patterns?
Methylation patterns are like tiny chemical dimmer switches attached to your genes. They turn certain genes up and turn others down based on environmental signals.
And the research shows these markers are moving faster in younger people.
Yes, the data demonstrates that people born after 1965 are exhibiting shorter telomeres and altered methylation patterns compared to people born in the early 1950s when they were the exact same chronological age.
Their biological clock is literally ticking faster.
It is. And crucially, this metric of accelerated aging is directly correlated with much higher risks for early-onset lung, gastrointestinal, and uterine cancers.
To synthesize this for you listening, the calendar on your wall might say you are 35.
Right.
But because of the cumulative effect of your modern exposome, the ultra-processed diet, the altered microbiome, the chronic low-grade inflammation, the decades of disrupted sleep, your cells are experiencing the environment of a much older body.
Exactly. The timeline of DNA damage has been put on fast forward.
You are chronologically young, but biologically, your cellular repair crews are just exhausted.
The fundamental mechanism of cancer hasn't changed. It is still a disease driven by accumulated DNA damage over time. What has changed is the speed of time itself on a cellular level.
Wow. And that reality brings us to the most tragic, practical consequence of this entire trend.
The human cost.
Yeah, the human cost. We have a medical system and, honestly, a societal mindset that is still operating entirely on the old rule book.
We do.
Because we still view cancer strictly as an old person's disease, young adults are slipping through the cracks with devastating results. There's a massive danger in the too young assumption.
We see the consequences of this cognitive bias constantly in the clinical data, particularly regarding early-onset colorectal cancer.
What happens in the clinic?
Well, because a 30-year-old is statistically assumed to be too young for colon cancer, both the patients and their primary care doctors frequently dismiss the early warning signs.
They just brush it off as something else.
Yes. A young adult presenting with abdominal pain, changes in bowel habits, or even rectal bleeding is routinely told it is just hemorrhoids or a minor fissure or irritable bowel syndrome brought on by work stress.
And I completely understand the psychology behind it from the patient's perspective.
Of course.
Going to the doctor is stressful enough, but going to the doctor to talk about your bowel movements is something most people actively dread.
It's embarrassing for a lot of people.
Right, so if a medical professional tells you it's just stress or hemorrhoids, your first instinct is pure relief.
You want to believe them.
You take the cream, you promise to eat more fiber, and you go home.
And the tragedy is that the cancer continues to silently grow.
Well, they think they just have IBS.
Exactly. By the time the symptoms become so severe and undeniable that a colonoscopy is finally ordered, the disease has often progressed from a highly treatable, localized polyp to a later stage invasive malignancy that has breached the colon wall.
That delay in diagnosis is literally costing lives.
It is.
Yeah.
This is why advocacy and awareness are paramount. We have to update the diagnostic algorithms in our own minds, and doctors need to update them in their clinics.
Which means I want to talk directly to you, the learner, right now. The most empowering, life-saving takeaway from all of this research is simple. Do not ignore persistent symptoms, regardless of the year on your birth certificate.
Absolutely.
You know your baseline body better than anyone else on Earth. If something is fundamentally wrong and it is not resolving after a couple of weeks, you must advocate for yourself.
Specifically, for the gastrointestinal cancers driving this trend, there are red flags you need to be vigilant about.
What should they look for?
Seeing blood in your stool. Do not just assume it is a hemorrhoid if it persists. Unexplained, unintentional weight loss, when you aren't trying to diet, is a major red flag that warrants investigation.
Okay, what else?
Ongoing chronic abdominal pain or cramping that doesn't go away. An unusual, unshakable fatigue that doesn't improve even after you get a full night's rest.
Persistent lumps anywhere on your body.
Yes. Or major lasting changes in your bowel habits. These all require a thorough medical evaluation, up to and including specialized imaging or a colonoscopy, whether you are 25 or 65.
Beyond knowing your own body, you have to know your family history.
This is so important.
We established earlier that inherited genetics only explain a relatively small portion of these early onset cases. But if you have that genetic predisposition combined with the modern exposome, your risk multiplies.
Knowing your family history is currently the single most effective tool we have to determine if you need to bypass standard screening protocols.
So if your parents had it, you need to be screened early.
Yes. If you have a first-degree relative, meaning a parent or a sibling who was diagnosed with early-onset colon cancer or early-onset breast cancer, your timeline changes entirely.
You do not wait until you are 45 to get a colonoscopy.
No. Depending on their age of diagnosis, you might need to start screening in your 20s or 30s. You have to initiate these conversations with your family members, as uncomfortable or frightening as they might be.
And ensure that history is clearly documented with your primary care doctor so they can't brush you off.
Exactly.
As we bring this deep dive to a close, I want to circle back to our mission statement.
The goal isn't fear.
Right. The goal of unpacking all this dense biology, the exposome, the microbial rainforest, the accelerated aging markers, it is not to paralyze you with fear. We don't want you staring at every meal you eat with suspicion or lying awake at night terrified because you didn't get 8 hours of sleep.
That would just increase your cortisol and make things worse.
Exactly. The goal here is empowerment.
Prevention is not about achieving biological perfection. Nobody can live a perfectly pristine life in the modern world.
No, we cannot completely control the air pollution in our cities, and we cannot undo the antibiotics we needed to survive childhood infections.
Prevention is about understanding the mechanisms and then making consistent choices that stack the odds in your favor.
Let's translate these complex mechanisms into an actionable playbook for the listener. Based directly on the consensus in the research, how do we build a bodily environment that is actively hostile to cancer development?
Okay, number one, regular movement. And the mechanism here isn't just about burning calories. Physical activity actively lowers circulating insulin levels and reduces systemic inflammation.
You are cooling down the fires in the city?
Exactly. Number two, a diet high in diverse dietary fiber and whole foods.
Because you now know the mechanism. You have to feed the rainforest in your gut so those beneficial bacteria can manufacture that protective butyrate shield for your colon DNA.
Right. Number three, fiercely prioritize your sleep architecture. Guard that time, because that is the critical window when your immune system performs its surveillance and your body repairs its daily DNA damage.
Number four, minimize your intake of ultra-processed foods. You are vastly reducing the inflammatory burden on your metabolic system.
Number five, lower your alcohol intake. Alcohol is a known cellular toxin that directly disrupts the gut microbiome ecosystem and fragments your sleep architecture.
Maintaining a healthy weight naturally reduces the hormonal growth signals and inflammatory cytokines sent out by active visceral fat.
And finally, get regular medical checkups and be radically, unapologetically honest with your doctor about your symptoms.
It comes down to making choices that lower the temperature of your internal environment.
By doing so, you are giving your cellular repair crews the time, the resources, and the stable environment they need to fix those tiny DNA typos before they ever become a threat.
If we step back and look at the overarching narrative of this research, it leaves us with a profound realization about what it means to be human in the 21st century.
It really does shift your perspective.
For a long time, we viewed our bodies as closed, isolated systems. But we are porous. We are deeply, inextricably connected to our environment.
The world outside of us inevitably shapes the cellular world inside of us.
And that is the ultimate takeaway. How can we cultivate more respect for that connection? The choices we make as a society about how we produce food, how we build cities, and how we manage stress are not just external political or economic issues.
We have biological issues.
The rising tide of early-onset cancer might just be one of the clearest, loudest warnings we have as a species.
It is telling us that the modern world isn't just changing our daily habits or how we commute or how we communicate.
The modern world is fundamentally changing the internal environment of the human body. The biological rules of our internal city are being aggressively rewritten by the external world we have built.
It's a lot to mull over.
It is. Thank you for joining us on this deep dive. We hope it has given you a new lens through which to view your own biology, listen to your body, advocate for your health, and stay curious.